Good morning, student. Today's our lecture is on vitamin C. So first we see the what are the learning objective of today's lecture. So learning objective of today's lecture is first we see the history part. Then what is the structure of vitamin C, and then how the vitamin C is synthesized in lower animal या तो non-primate. Is vitamin C synthesized in human or not? And if not, then why? Then we see the sources from where we get the vitamin C. Then what is the recommended daily allowance of the vitamin C? And then next most important part is the function of the vitamin C. What are the biochemical reaction where we require the vitamin C? And what happen if there is a deficiency of vitamin C? What is the disease name? What is the manifestation? How we diagnose and how we treat the vitamin C? And in the last, what is the toxicity symptom of vitamin C? So let's get started with the history part. In 1948, vitamin C deficiency leads to scurvy is identified, and in 1930, Albert Gairogi isolated the vitamin C, and in 1933, Howard established chemical structure of vitamin C and gave the name ascorbic acid. So coming to the structure, so vitamins, this is a vitamin C structure. It looks like, can you see? It look like monosaccharide, ring structure of monosaccharide. So what is the peculiar feature about this structure? There is a enediol. So this has a strong reducing property. And vitamin C has present in two forms. One is L-ascorbic acid and second one is the dehydroascorbic acid. These are the interconvertible depending upon the chemical reaction they catalyze. So then we see the some chemistry part. So all we know that the vitamin C is the water soluble vitamin and easily destroyed by the heat, alkali and storage, and in process of cooking 70% of vitamin C is lost. And as I said earlier, it's look like a carbohydrate. Its structure is look like a monosaccharide of carbohydrate, and it has a strong reducing property. Now coming to the how vitamin C is synthesized. So vitamin C is synthesized in lower animal in non-primate by uronic acid pathway from the D-glucose or D-galactose. And the vitamin C cannot synthesize in human. Why? Because there is a deficiency of an enzyme called L-gulonolactone oxidase. Because of this, vitamin C cannot synthesize in human. This is a L-gulonolactone oxidase. So this enzyme is not present in human. So vitamin C cannot be synthesized in human. Now coming to the sources from where we get the vitamin C. All we know that the vitamin C is present in the citrus fruit and vegetable like guava, lemon, pineapple, papaya, orange, broccoli, strawberry, Indian gooseberry. All these are the rich sources of vitamin C. And remember one thing, milk is a poor source of vitamin C. Now coming to recommended daily allowance of vitamin C. So vitamin C RDA depends on the age and the gender. Also the requirement increase during pregnancy and lactation, but on an average we require the 60 to 90 milligram per day. This is a RDA. And then coming to the most important part of vitamin C is the biochemical function of vitamin C. First, vitamin C has a two important function. You must know at least two functions. One is the antioxidant function. One is the antioxidant function of vitamin C. They defend against the free radical and oxidative stress. And second important function is vitamin C act as a cofactor in hydroxylation reaction. Because of this, vitamin C has a role in collagen formation. Okay. Now coming to the all the function of vitamin C. So vitamin C has a many function, like vitamin C required for the collagen synthesis, carnitine synthesis, tyrosine metabolism and catabolism, neurotransmitter synthesis, drug and steroid metabolism. It also maintains the iron and copper in the ferrous state, reduced state. In addition, vitamin C also acts as a reducing agent in many enzymatic reactions. And in the last, as I said earlier, it is a potent antioxidant. It is a lipid phase antioxidant. Okay. So now coming to the each function one by one. So first most important function is the antioxidant function. All we know that the hydrogen peroxide is the reactive oxygen species, and hydrogen peroxide is broken down by the enzyme glutathione peroxidase by glutathione peroxidase into H2O2 into water. H2O2 into water. An enzyme is a glutathione peroxidase. But during this reaction, this reduced glutathione is converted into oxidized glutathione. This must be converted again into reduced form. This happens with the help of vitamin C. Another vitamin C also vitamin all we know that the vitamin E is also antioxidant vitamin. They reduce the free radical, peroxide radical, and itself get tocopherol radical form. This alpha tocopheroxy radical again converted to normal alpha tocopherol with the help of vitamin C. And this also known as the vitamin C has a sparing effect on vitamin E. This is the link pathway. The free radical lipid peroxide is neutralized by vitamin E, and vitamin E itself get converted into radical form, and this radical form again converted into normal alpha tocopherol with the help of vitamin C. Vitamin C also reduce the oxidized glutathione, thyroidoxine, and lipoid into reduced form. So these are the antioxidant function of vitamin C. Now coming to the which is a donor in vitamin C. This slide shows that the ascorbate donate the hydrogen atom and oxidize the free radical, and these are the some chemical reaction. Vitamin C neutralize the superoxide. Okay. Now coming to the second most important function of the vitamin C. Vitamins, as I said earlier, vitamin C has a role in hydroxylation reaction, and most important function of this hydroxylation reaction in collagen synthesis, in collagen cross-linking. So for the collagen cross-linking, which require the hydroxyl group. So vitamin C causes the hydroxylation of two amino acids. One is the proline and second one is the lysine. So these two enzymes, prolyl and lysyl hydroxylase, help in a hydroxylation reaction in the collagen synthesis, and then this hydroxylation help in the collagen cross-linking and collagen maturation. This first have the proline converted into hydroxyproline with the help of proline hydroxylase enzyme. It requires the vitamin C, it requires the Fe+2, it requires the oxygen, and it requires the succinate. Now coming to the second part, lysine converted into hydroxylysine. This also lysine hydroxylase enzyme which require the vitamin C and ferrous iron and oxygen. Mm, Now now coming to the carnitine synthesis. In carnitine is synthesized from lysine and then adding of methyl group. So carnitine is made up of two amino acids, lysine and methionine. And during the carnitine synthesis, there are many hydroxylation reactions which require the vitamin C. What is the role of carnitine? Carnitine has a role in transport of long chain fatty acid into the mitochondria from the cytosol with the help of carnitine system. Now coming to the third function in tyrosine metabolism. So all we know that during the tyrosine metabolism there is a formation of dopa and dopamine. Then the conversion of dopamine into norepinephrine by dopamine monooxygenase enzyme also require the vitamin C. Okay. Now coming to the tyrosine catabolism. Tyrosine converted to para-hydroxyphenylpyruvic acid, and this para-hydroxyphenylpyruvic is converted into homogenesic acid with the help of the enzyme phenylhydroxypyruvate dioxygenase. This also requires the vitamin C. Then next role of vitamin C in tryptophan metabolism. So conversion of tryptophan into 5-hydroxytryptophan required the vitamin C. Okay. Now next coming to the bile acid synthesis. What is the rate limiting step, main enzyme of bile acid synthesis, and from where bile acid is synthesized? So bile is synthesized from the cholesterol. Okay. And the enzyme for this bile acid synthesis is 7 alpha hydroxylase enzyme. This convert the cholesterol into 7 alpha hydroxycholesterol, and which require the vitamin C. Now next coming to the hormone synthesis, like peptide hormone synthesis, steroid hormone synthesis, there are also many hydroxylation reactions which require the vitamin C. Vitamin C also has a role in iron absorption. How? All we know that the iron is absorbed in the ferrous state. Okay, so this vitamin C reduce this, and in vitamin C iron present in the diet is in ferric form. Okay, this ferric ion is converted into ferrous with the help of vitamin C. Okay, by this vitamin C increase the iron absorption from the intestinal cell. This vitamin C also has a role in formation of tetrahydrofolate, okay, by folic acid into the folic acid converted into tetrahydrofolate with the help of the folate reductase enzyme. This also requires the vitamin C. Now next coming to the what is methemoglobin? When in normal heme iron is present in ferrous state. If this converted into ferric form, then it form the methemoglobin. Okay, so this methemoglobin convert to normal hemoglobin with the help of vitamin C. Okay, now coming to what happen if there is a deficiency of vitamin C. Deficiency of vitamin C leads to disease called scurvy. It is a disease of historical origin. Okay, nowadays vitamin C deficiency is very rare. What are the different clinical manifestation of scurvy? The most important clinical manifestation of vitamin C deficiency is bleeding manifestation. Why there is a bleeding manifestation? Because vitamin C has a role in collagen formation, and this collagen is present in gum, blood vessel, bone, etc. So there is a swollen, spongy bleeding gum. The capillary also become fragile and bleed easily. So there is a subcutaneous bleeding under the skin. Small dot-like patches also there. This is called petechiae. Relatively larger page is called ecchymosis, and larger accumulation of blood in subcutaneous tissue leads to formation of hematoma. Severe bleeding from the node is known as the epistaxis. Retinal bleeding can also occur, and hematuria can also occur. What is hematuria? It blood in the urine, and there is also melena, blood in the stool. So these all are the bleeding manifestation of vitamin C. So what are the bleeding manifestation? Bleeding gum, petechiae, ecchymosis, subcutaneous bleeding, hematoma, epistaxis, hematuria, melena. Also in bone there is a collagen. So this bone in case of vitamin C become weak and fragile. Fracture on the slightest trauma or pressure. This is known as the scorbutic rosary, scorbutic bone. Okay, this is known as the scorbutic bone. Beaded appearance of chest. This and depressed sternum is also known as the scorbutic rosary. Hemarthrosis. What is hemarthrosis? Bleeding into joint, and this leads to pseudoparalysis. There is also poor wound healing. Why? Because in repair, normalization of wound require the collagen synthesis, proper collagen. So there is no proper collagen leads to poor wound healing, and there is anemia. Why there is anemia in scurvy? As I said, vitamin C is required for the conversion of ferric into ferrous, and ferrous is absorbed through the intestine. So if there is a vitamin C deficiency, this iron absorption does not take place, and it leads to iron deficiency anemia. How we assess the vitamin C deficiency? By blood or WBC, vitamin C level at the ascorbic level. What is the treatment? Vitamin C supplementation given orally in adult 800 to 1000 milligram per day for at least 1 week, and then 400 milligram per day until complete recovery is happen. And in children the dose is somewhat less, 150 to 300 milligram per day for 1 month should be given. And improvement of symptom is usually noticed within the 24 hours. So this is the treatment part. Now coming to toxicity. The toxicity of vitamin C is actually rare, and if we take a very mega dose of vitamin C supplement, that might cause the toxicity symptom. What are the toxicity symptoms? These are the diarrhea, nausea, vomiting, heartburn, abdominal cramps, headache, and insomnia like symptoms happen.